Okay. Yeah. So yeah. So basically, what we are talking about when we are talking about the quotient rule, uh, this is a situation where you are trying to differentiate a function which has a numerator and a denominator. Okay. So in this particular case, you want to use the what? You want to use the quotient rule. So this is a very important rule. And so one thing that I would like to stress is that you cannot interchange the position of the letters that we'll be talking about, or else your value is going to be wrong. So it means that what you choose to be your u and to be your v, maintain them until you are done with your question, right? So don't do, I think for this one I'm going to take it as a u, going to take this as a v. You don't do that. So you want to stick with your what? You want to stick with what you've started with, right? So I think that's good introduction, I would say. So I think now we can be able to proceed and talk about the actual quotient rule. So after the quotient rule, then we'll talk about trigonometric functions. So the quotient rule, like I said, you want to use it in cases where you have u over v. So basically, you've got u, that's a function, and v, that's a function as well, right? And then you want to derive that, or you want to differentiate that rather. So how you do it is dy dx is equal to, so you're going to write your v, then you're going to say du dx, then you're going to have u, then you're going to have dv dx all over v squared. So I know that looks a lot, but the other one which you would want to use and know is, I think this one looks less involving. The way you say v, and then you say v, and then u prime. So that's v, then u prime, then you say u and the derivative of v, which is the v prime over v squared. So yeah, it's just basically the same thing, just written differently, right? So that's the approach. So v derivative of u minus u derivative of v over v squared. So that's your what? That's your quotient rule. So that's basically about the quotient rule. So now let's now be able to look at an example, and then just to be able to see how we can be able to appreciate that. So since we talked about how you can differentiate these things yesterday, so I think today we'll just be able to just go straight to the answers, since we discussed how to do these things yesterday. So what we are going to do here is, you first want, okay, so here is our question. So here is our, the question is differentiate so you are differentiating that, right? So you are differentiating x minus 3 everything raised to power 2, and then also x plus 2 everything raised to power 2. So there, of course, for yeah, you get your u to be x minus 3 squared, v, you take it to be x plus 2 squared. Then the derivative for du dx, we discussed a lot how to find this. So you just drop the 2 there, and then you reduce that, 2 minus 1, you just have 1 there, right? Then for v, for the function d, that's dv dx, we do the same thing. It's going to be 2x plus 2, then you're going to have 1 there on top, right? So that's basically how you go about it. So now we just have to just plug in these things. So really, once you remember the formula, usually much of the time is going to go into you simplifying your what? You simplifying your equation. That's where the bulk of the time is going to go into with regards to these questions, right? So that's something that's very, very important to take note of. All right. Okay. So now, at this point, what we are going to do is, okay. So now at this point, we are now going to substitute our things in the equation. So we are going to say just to create space. So we are then going to say dy dx. So we plug in v, then multiply derivative of u minus u, okay, let me just write properly, u which is x minus 3 squared like that. Oh, sorry, I missed something here. It has to be x plus 2, okay, squared. Then here this one is going to be derivative of v. Okay, then all over v squared. So we write v, then square it like that, then you square it. Okay, great. So now what you're going to do here is that's what I was saying, where you want to be able to simplify these things. Yeah, so you want to be able to simplify these things. So what you're going to do is, we can expand. We know the quick way of expanding, isn't it? So we know the quick way of expanding. Okay, or before we can expand, there's actually somewhat a quick way in which we can be able to look at this. If we wanted, we could say, since you see that x plus 2 is appearing at some point on top and also down, so what you'd want to do is, you may want to factor out this particular equation. You may want to factor out x plus 2. Okay, so what you want to do is, you may want to factor out, and then we'll be able to simplify it later on. So what you do is, I'm going to say if everything on top, if I factor out x plus 2, what's going to remain? So if I factor out x plus 2, and remember, we can't factor out x plus 2 squared, because the part on the left on top, or sorry, on the right, uh, only has a single x plus 2. So that's why we're just using a single one. So if we factor it, so what we're going to get is So factoring, we have that, then we have, and yeah, so of course we can even factor out the other thing, but for now we want to first simplify the what, we first want to, but if we want, I think let's even simplify, even let's even factor out even the other one, but it won't really do much good at this point, so let's just leave it like that. So we factored that out, and then we can leave this one, and then we are going to have a 2, just a 2, just a 2, huh? The 2 that was this side, it's been left, it's now come in front, right? Since that other one has been, this, that x plus 2 has been removed. Then now down, we know that this is x plus 2 to power 4, so it's the same as x plus 2 and then x plus 2 to power 3. Remember, with your indices, if you are multiplying, you just add the indices, so you know that that's still 4, right? But we've just used that so that we can be able to cancel this. So you know that that cancels, that cancels. So meaning our equation has now remained as what? Our equation has now remained as, so we can write the 2 in front just to be able to make it look neater. So here you see we've already done the factorizing, sorry, we've already done the differentiation, but it's the simplification part which has got which is crucial. Yeah, because they always want you to simplify this expression, and okay, yeah, so and that's where the marks, okay, of course the differentiation is going to have marks, but also they expect you to be able to use some algebra to simplify this, right? So after doing this, okay, let's just you take it up to there. So after doing this, then what you want to do is, um what then can you do? You just expand this, right? So if you want, you can expand. If you want, yeah, if you want, you can expand. But if you want, you can actually say, let me expand, and then see maybe there are certain things which I can be able to cancel out from this. So you start. So expanding, first you want to get the 2 out. X, you are going to have x squared. Then x and minus 3, you're going to have minus 3x. Then that you're going to have 2x, and then you're going to have negative 6. Okay, so let me just write things properly. So you're going to have positive 2x, then minus 6, then you're going to have 2, then you square that, you're going to have x squared minus 6x plus 9. That's how you go about it. Then all over what? All over x plus 2 cubed. Then once you do this, you then multiply through. So here you know that this 2 is just going to be a what? A negative x, isn't it? When you reduce it. So you're going to have that, then minus x, minus 6, and then that. And then all over what? X plus 2 cubed. Okay, we are almost done. Okay, so now after this, then you want to generally expand. So that's going to be 2x. Then that's 2x squared. That's 2x. That's going to be 12. That's 2x squared. That's going to be positive 12x and minus 18. Then that's going to be x plus 2, and then that. Okay, so what then? Okay, so let me just check the battery. Okay, I think it can be able to take us. Okay, let's just see how far the battery will take us, but I think it should be able to do us good. So okay, yeah, so now you see that this and that cancels, right? And then this and that you're getting 10x, and then this and that you're getting negative 30, negative 30 over what, over x plus 2, like that. If you want, you can even factor out the 10, you have the 3 there, and then you have the x plus 2, like that. That's your answer. So that's your dy dx. So yeah, so you see, usually you see that the differentiation itself doesn't usually take a lot of time, but it's really the working that follows. It's the wake up that follows. So I think maybe we can look at maybe one last example. Yeah, maybe just look at one last example, and then yeah, especially one that is involving a square root, so that we can have that idea. Then we can look at the trigonometric ones. Then we can look at the trigonometric ones. So what we are having now is differentiate. So differentiate x okay, so x over square root open bracket 1 plus x squared, right? So here you want to be able to figure out what is your u and what's your what and what's your v. So of course we are going to say our u is x, our v is that. Of which we can always write this as okay. So meaning from this we can be able to differentiate, which was what we are talking about yesterday. So meaning yeah, we just differentiate. So du dx is just going to be a 1. Then for dv dx it's going to be x 1 plus x squared minus 1 over 2. So those are the things that we are going to work with. So once you do that, then you now want to plug everything that you have into the formula. Yes?
Why has the X come out? X button for DVD.
Were you there yesterday?
Yes.
All right. Okay. Uh oh. Okay. So I skipped the process because this was what we discussed anyway. So let me write everything so that you can follow through. So remember that's going to be what? That's going to be 2x. Just try to check through the things we did yesterday. Yeah, so that's going to be you define you what do you do? Yeah, so you differentiate what's in the brackets. Okay, that, and then you're going to have just use the chain rule. I'm just using the chain rule. So you're going to have that and that and that. So then what you're going to have, this cancels that. So remember, this 2x just came from differentiating the x squared that was in the bracket, right? That's what the chain rule entails, like we discussed yesterday. Okay, so my encouragement is that whenever we discuss, kindly go through so that we can build up from there, so that we can, yeah. So that's how we are reaching at that. But I just wrote it like that since I know that that's something that we looked at in detail yesterday. But yeah, so that's how they got it. So you just basically use the chain rule. What's in the bracket is going to be your u. So you differentiate what's in your bracket, and then you take that your u, you differentiate it as being what it is, u raised to power what? Raised to power half, and then the half comes to the side like the n, the way we are doing it, and then you subtract 1 from the half. That's how you are getting negative half. So that's what we are discussing. So whenever we discuss something, it would be good to go through it before we meet, because once we discuss something, I assume that we've revised through and we are comfortable with them. Okay, so now for everything that we've now found, we just now plug them into the equation. Let me just check the battery. Okay, so we're having v du dx, and then we are having u dv dx all over v squared. So basically we go and then just begin to plug in our values. So we know what is v. V is 1 plus x squared and half times du dx, which is just 1. Then u, oh sorry, u, yeah, u, okay, where is u? Okay, yeah, so u is just x, then dv dx, that's what we found there, right? So we found that, that, that. Okay, so that's that. Then over v squared. So v squared. So v squared. Now there is a way that I'm going to write this. I'm going to write it with a square root so that you can see that we are squaring a square root. Okay, but if you want, I could have written it the way I wrote it on top, but I prefer writing it with a square root so that you see that because we are squaring it, that's why the square root on the denominator is going to be what? Is going to be removed. Okay, so that's why the square root there is going to be removed. But if you wanted, even if you had that and that, you can still be able to, if you square that, remember indices, you multiply, that's 1, that's half times 2, that's going to be what? That's going to be just 1, and we don't show the 1, so that's how we're going to arrive at that, where we get rid of the square root. So that's about it. Then once you reach at this point again, really the top the hard part has really been done. It's just really with the simplifications. So how you want to simplify this is, so what we are going to do then is, so you're going then to rewrite this as, so you want to write this as So that's that. And now I'm going to introduce a square root again. For one reason, I'm going to explain so that you can be able to see it like this. When you see it with a square root, it will be easy. It will be easier for you to see what we are going to do. So now you see there is that. Then down is just a normal because the square root has been cancelled by the square. So now what now we are going to have is we see that what we have is almost something like a what? Something almost like a difference of what? Something like a difference of two squares, isn't it? Now, what you would want to do at this point is this. You know that what does this negative half signify? Negative half signifies that you can act. Oh, sorry, there should be a two to this. So what negative half signifies is this the things which are in the brackets, okay, signifies that the things which are in the brackets they can actually go down, okay, like they can actually be written as they can actually go down. So let me just uh, show that properly. So you have that and then x squared. So now remember your rules. You can actually write 1 over what? This can now go down. I hope you remember that rule of indices, right? So that can go down, and we know that down already there is what? There is 1 plus x squared. Now, with where we've now reached, you know that you can add, since the two things in the brackets are the same, so what you can do is that you can add the two indices, okay? So here there is 1 and here there is 1 over 2. So that's basically like 3 over 2, isn't it? That's 3 over 2. So I mean that the denominator, we can combine the two and just raise them to what? Raise them to a single power of raise them to a single power of 3 over 2. So we can raise them to a single power of that. Okay, so what we are having is the numerator is that and then minus x squared all over 1 x squared 3 over 2. Okay, now with where we've now reached, you then want now to, okay, so now with where now we've reached, we may now want to, okay, what can we do at this juncture? Okay, yeah, so okay, yeah, so that's what I wanted to say. So at this particular juncture which we've reached, you can now be able to okay, I think I may have missed a step, right? Okay, so you remember last time when we were talking about whenever you've got a complex fraction, right? You remember me saying that when you've got a complex fraction, how you actually deal with it is you want to find the common denominator for the two functions which you have, isn't it? So you are trying to find the what? You are trying to find the common denominator for the what's this? For the fractions that you have. So meaning that for this particular one, you are basically saying it's x squared, and then you are saying quite alright, like we said, 1 over what you are having in the brackets, okay, and then half. Yeah, so just pardon that. Yeah, then over half, right? That's that. Or if you want, you can put square root if you want, or square root, that would be fine. then the bottom part remains the same as it was. Then remember, what was the rule for us doing this? We then say, since there is a complex fraction, the part which is down, or this one on the left, it's simply the same as that over 1, isn't it? So let me just rewrite it like that so that it can be clear about what I'm talking about. So you can actually rewrite this particular function and say this function is the same as okay, let me just write it properly. So it's the same as square root 1 x squared over 1. Yeah, so remember, like we were doing, so if you want, you can then multiply both the so you multiply both the denominator of this entire function, so this entire numerator, you multiply both on top and down by what? By the common denominator of the numerator. Okay, so you want to find what's the common denominator of this, of the numerator. So you are going to say, so the common denominator, let me write it in red so that we can be able to differentiate it from everything else that we are doing. So the common denominator is going to be what? Is going to be that. Okay, then there is that. So since this is the same as x, that and that. Okay, yeah. So meaning, what's the common denominator? So you see that your common denominator is going to be that. Am I writing like that? Yeah. So the common denominator is going to be 1 plus x squared, that, and then, so yeah, so meaning that when you multiply that, you're going to get, so it's going to be this multiplied by that, right, which are going to have both square roots, huh? So those square roots are going to cancel, right? Like we remember, if you've got v square root and that, you're basically going to get a, isn't it? So that's what has happened there. Okay, so that's what has happened there. Then on this other part, what's happening is you put a 1 here, you put this here, it's 1. Then here you're going to have what? X squared, isn't it? Yeah, so that's basically what's happening. But remember, what do you do? Like we've been doing, you will remember, we simply say you are multiplying both the both the numerator and the denominator by what? By the common denominator. By the common denominator of the numerator. Okay, quite some terminology there, but that's about it, right? So hope we've really got, we've really understood how we'll be getting those answers. So now, so remember, you do it both up and down, and I'm sure you remember that we are doing these for the earlier questions that we had looked at. So especially on limits, on simplifying limits. So what you do, you're going to do that, right? So in this case, it will be difficult for you to see how this relates with this, but once you understand that this is the same as, okay, so once you understand that this is the same as 1 over 2, it becomes easy for you to relate how we are going to find our answers. Okay, so it's basically the same thing, isn't it? But we know from what we've already calculated, we know what our value on top is going to be. It's going to be that, right? And then minus x squared, then over, so we're just adding the indices. Remember, if the things which are in the brackets are the same, you just add the indices. So that's going to be 1 plus half, so that's 3 over 2. So that's going to be 3 over 2. So it's going to be 3 over 2. 3 over 2, isn't it? Then now you know here you can simplify further by saying 1x squared minus x squared over 1 plus x squared 3 over 2. So that's 3 over 2. So you can cancel that, cancel that. That's going to be 1 over. Okay, let me just write. Oh, yeah. Okay, yeah. So it's going to be 1 over 1 plus x 3 over 2. So you can see just from how it was all over the place, for it to just be 1 over open bracket 1 plus x squared 3 over 2. So that's why the simplification usually carries a lot of marks, because many people can just end midway. So it's just the thing. Remember, like I was saying for the earlier parts, that every time you encounter every time you encounter a complex fraction, you always have to multiply both the numerator and the denominator with what? With the common denominator of the numerator, which has got the complex fractions. I'm sure that's something that we really talked about a lot when we are discussing limits. So now, before we can go into the trigonometric ones, can we do a similar example, or maybe we can proceed to the trigonometric questions? So for this one, I want to hear from you. Please respond quickly so that we can proceed.
Definitely, I think we can proceed.
Okay. Does everyone else feel the same? Hello. Does everyone else feel the same? Okay. Okay. So we are going to proceed. So really, the key things when it comes to the trigonometric equations, or differentiating trigonometric equations, for the trigonometry, it's all about knowing the rules. Okay, so it's always about knowing the rules. So we're going to go through some of the rules, and then we'll see with the time that's remaining if we can just be able to do one or two questions. Then we'll also look at the differentiations of logs and everything. But we can't really talk about anything pretty much before we even define what the what the derivatives are going to be for these particular functions, right? So you have to know what sign is going to be when when you're differentiating, what is going to turn into. So these are key things. We can't talk about differentiating these things without bringing these things out, right? So one thing that you want to realize first of all is that whenever you are differentiating sign, okay, it will go to cos, right? But usually whenever you are differentiating something that is starting with c, your derivative is going to have a negative in front of it. Just get that rule. So let's see how this one comes. So we've got y is what? Y is sin x, derivative is what? Derivative is cos x. Then you've got y is cos x dy dx is what? Dy dx, we said if it's starting with a c, it's going to have a negative. So it's going to be negative sin x. Okay? And we'll see also how cosec has a negative because of that general rule that I've given us. Huh? Then you'd say y is tan and dy dx is it's going to be positive, huh? It's going to be positive secant squared. Okay, going to be secant squared. So that's those are important things you'd want to know. So we can now add others, because we can't, there's no way we can discuss trigonometric derivatives without knowing these things, because once you know these things, everything else just becomes pretty much easy. So cosec, so remember cosec starts with a c, isn't it? So yeah, this derivative is going to have a negative, huh? Excuse me, pardon me. So it's going to have a negative, right? Okay, let me just check on the battery. Okay, yeah, so it's going to have a what? It's going to have a negative. So it's going to be negative cosec x and cotangent x, which makes sense because remember cosec is 1 over cos, 1 over cos, but anyways, you know them, huh? Then for y, you're having sec x. Oh, sorry, I didn't write the second one properly. I'm supposed to indicate that it's dy dx, huh? The derivative. So it's, remember, it's going to have negative, huh? Then cot x. Okay. Then now for the sec, so if we've got y is equals to sec if y is equals to sec x, so dy dx is going to be sec x tan x. Okay, then if y is cot x, okay, so if y is cot x, then dy dx is going to be what? Remember, this has got starting with a c, so you have a what? Your derivative is having a negative, isn't it? So that's how you remember which ones has got a negative and which one has got a positive with regards to derivatives. So having done these things, then now I think we are now able to be able to answer the questions that follow. Huh? I think now we are able to answer the questions that follow. So let's look at this question. So we've got f of x is x cubed. So in case you have written those things down, practice them, and then they will be helpful. So we're just starting with pretty much the basics, so that we can be able to build on these and be able to revise them. Huh? Okay. So now, for the okay, so derivative. So can someone be telling me what the derivative is going to be? So for the first one, it's going to be what? Can someone tell me? Remember, it's the same as what? X power n. So the n comes here, then n minus 1. Huh? So the n is the 3, the x remains x, then 2 or 3 minus 1, so that's 2. So then you've done that. Then for sine, what's the derivative for sine? It's cos x. Then you write, remember the constant rule. What does the constant rule says? The constant rule says if you've got a number in front and then you've got something, a function there, you can get the function out, then you can do the derivative, then you just command what? You just command multiply them together, right? So you can do that. That's if there is multiplication. You know that if there is addition or subtraction between them, you know of course that you'd have to treat the constant. When you differentiate it, it becomes zero, isn't it? Yeah. So now for this one, for cos, there is the 4 there. Now remember, cos, what's the derivative of cos? What's the derivative of cos? Derivative of cos is negative sine x. Okay, so that's that, right? So now, okay, let me just let me plug in the charger for this, because this thing is going to go off on us. Okay, so let's just do that. Okay, great. Yeah, so now, so that's that, right? So now what do we do? So then what we are going to do is going to now write our answer like this. So we're going to have okay, let's just clean our clean our working space so that things don't get mixed up. So we've got 3x squared plus cos x minus sine x minus 4. So that's how you would go about a question like that. Okay, so I know that was basic, but so it's good to start from those places. So then let's look at 3. So can someone tell me, from just what we've discussed, will the derivative for cosec have a positive or a negative in front of it? Okay, yeah, it's going to have a negative. Why? Because cosec is starting with a c. Okay, so that's how you remember, because usually most people, they remember the derivative, but then they'll make a mistake on the signs. They'll make a mistake on the signs. So what you're going to have is, okay, then you also have 4 sec x. Okay, so for these questions which are straightforward like this, it just really goes back if you're able to remember your derivatives, to be honest. So what you do, remember the rule of the constant, you leave the constant out. Then of course we said it to be negative, so cosec negative, then cot x, then you're going to have uh, plus 9. So the same rule of constant, you do that, then you're going to have sec becomes what? Sec x tan x. So sec x tan x, isn't it? Then you can now rewrite everything properly. So then to write everything, you're going to say, not write everything neat. So you just basically want to remove the brackets. So this 3 becomes negative 3 cosec x cot x plus 9 sec squared minus 4 sec x tan x. So that's how you'd write it. Okay, so that's how you'd go about it. So let's see if we can do the last one in this remaining time. Okay, so I'm sure now you may have noticed that now the questions that we are now doing, they've now gone a little bit up. Huh? So now here you've now got a what? A product. We now have a product rule. So here we have to make use of the product rule, isn't it? So what does the product rule tell us? So it tells us what you do is uh, okay. So the product rule entails that you get the what? You get the u, then multiply by the what? Multiply by the derivative of v, and then you get v multiplied by the derivative of what? Of the u. So there you have to make use of it. Huh? So meaning what's our u? I like getting u to be the first thing. Then you are going to get the v being the sign. So meaning the derivative of u, that's u prime, is simply going to be 2x. Then the derivative of v, which is say v prime, is going to be cos x. There is no negative cos. We are moving from sine to cos. Huh? Okay, so now what's going to be our dy dx? So our dy dx is going to be, remember we said it's going to be u, okay, and dv dx, or the derivative of v plus, okay, plus v multiplied by the derivative of u, isn't it? So that's basically how you are going to go about this. So since we have everything, we just substitute. So what's our u? Our u is x squared. V is, okay, so the v part, so the v derivative part is cos that, isn't it? Then what's our v? V is sin x. Then u prime, or derivative of u, is 2x, isn't it? So what then we are having is, we have x squared, sorry, so we got um, okay, so you have that plus 2x sin x. Okay, so I'm sure that's why maybe perhaps yesterday you heard me say we'll first have to go through the product rule, the quotient rule, and all these rules before we can be able to what? Before we can be able to look at the trigonometric, because it all just goes back. So the key thing is just know what this differentiates to, and then just, of course, there will be some which will have the quotient rule, some will have the, some have the quotient rule, some will have different rules, are the chain rule. So once we've, of course, we've built the fundamentals, then entails that, yeah, so tomorrow we'll just look at a couple of questions, and then we'll also look at the derivatives of logs, and then we can start the maxima and the minima questions. So